Good morning and welcome. I'd like to begin our meeting today with a quote from a key thought leader in the area of assessment that I feel encapsulates the challenge of engaging students at the right level, where he states, "If students learnt everything that we taught, we wouldn't need to assess." Now, my aim today is to not only show you a range of assessment strategies, but to get you to question your choice of assessment in mathematics and its impact on your students' learning and teaching experience. The Australian curriculum articulates that today, more than ever before, as educators, we need to provide an inclusive and differentiated program to cater for our broad range of learners. Our ultimate aim, as researchers such as Black put it, is that our student develops a mathematical literacy to assist them to become independent and effective learners. Now, assessment in mathematics, therefore, plays an integral role in that it provides a window to a student's thinking and a compass to instruction, and therefore has a direct impact on the teaching and learning process itself. With new understandings emerging about how our students learn, assessment practices have evolved from measuring what a student has learned to that of how the student has learned in the ways of formative assessment, and is geared towards helping both the teacher and the students, as this slide suggests. Whilst there is a myriad of assessment strategies that we could review, we will specifically focus on student self-assessment and that of a standard paper and pencil test. Student self-assessment is a strategy that works on the premise that when students evaluate their own work, the responsibility for learning becomes theirs. So let's look at this principle in practice. Let's say we're in the Australian Curriculum Content Descriptor ACMNA 125, comparing fractions with related denominators. Now, looking at this question, leaving it at that would just be a summative problem. But by adding the following, you're in effect asking students to articulate the kind of strategies and mental processes that they would be drawing upon. Now, using this formative approach, it is clear to see that student 1 may need more support in their understanding of equivalent fractions and the density property of fractions, and therefore informs the teacher for future instruction. The benefits, therefore, is that by promoting self-evaluation and metacognitive strategies, students become engaged in their own learning, which can in turn eliminate weaknesses and improve student learning. From the teacher's perspective, this approach supports diversity in that it enables the teacher to readily identify student strengths and pinpoint any underlying weaknesses at the time of instruction, helping you as the teacher to tailor your next steps to each student's needs. The limitations, however, are that students are not naturally self-evaluative, and as a teacher you need to invest time and commitment to train students in the process of self-assessment. That being said, while setting up the process may be time-consuming, the gains in student achievement and ability will allow you as a teacher to allocate your time more effectively with your students. The findings of such assessment can be recorded in the form of a checklist, which can be referred to ensure that any misconceptions or consistent patterns of error are addressed early, and can also be used as part of the reporting purposes to relevant stakeholders such as parents and the school. Another way you could record self-assessment could be through the introduction of a reflective mathematical journal, which can help to demonstrate a student's level of understanding, any misconceptions, and the nature of strategies they utilize, and may form a topic of discussion between teacher and child during a class interview. In sharp contrast, summative assessment such as the standard paper and pencil test at the end of a unit documents what the student knows and is capable of doing after instruction. Whilst the tests may be quick and easy to administer, this information is often what is used to assign grades and to inform teaching. The limitations here are that this kind of assessment serves very little in the way of engaging students in the teaching and learning experience itself. As was the case in student 1 in our previous example, as whilst their answer was correct, little was learnt about the strategies and thought processes that they used. As a matter of fact, research suggests that summative assessment can in fact have a detrimental effect on a child's motivation, as low-performing students' engagement in mathematics is undermined by the awarding of grades. Despite all this, summative assessment still has a place, for when it's used at the beginning of a unit of work, it can be very effective to inform our teaching to ensure that we are offering an inclusive and engaging lessons that are pitched at just the right level. In recent years, there's been a move to align summative assessment with the curriculum, and in doing so, align both formative and summative strategies in a way that are complementary rather than undermining. In conclusion, as the practitioners who actually make things happen, I hope that the above critique of formative and summative assessment makes you look more closely at what we assess and how we assess what our children do each day to ensure that we build strong foundations in mathematics. Any questions?